Hello, everyone. Welcome to another binary episode of the Day Zero podcast. I'm Spectre. With me is Z. As per usual, we'll cover the Spot the Vuln challenge solution, and then we'll get into some of our topics. So, Z, I'll let you take that away.
Yeah, this week's Spot the Vuln, so I'm zoomed in for you guys who are able to watch right now. This week's Spot the Vuln, I did use a slightly non-standard, or very non-standard Python JWT library, so I include the link on that. This is kind of one of those things that maybe isn't super obvious just reading the code. You would want to reference the documentation, or at least that does make it a little bit easier to figure out, but the gist here, Python JWT, they offer this function process JWT, and then you give it the token to actually process, and it'll give you the headers and the claims from it. The idea there is you're using that to get information for, like, say, to know who the issuer was, so then you can get the key to actually validate it. But in this case, they're just using process JWT, pulling data right out of the claims without actually verifying it. And process JWT does not verify it. And it kind of comes down to the idea of, the APIs you expose. It just makes it really easy to abuse it in this case. They do document the fact that it's an inappropriate use to just use it like this, but it still happens in code. It's not the most popular library, but having kind of an API that either just doesn't allow it or lets you provide, say, multiple keys or check the issuer in some other way would be better than providing access to the claims, but whatever. I mean, they made their choice, and this is just an improper use of the API or the interface that's exposed.
Yeah, I believe when you were mentioning this issue to me, you said there was a different function that should have been used that would check the issuer.
Yeah, there's also a verified JWT that would check that the token's actually signed and everything's good on the token itself. So it would return an error or it would give you an error before giving you the claims out of it.
Bit of a different issue as far as the Spot the Vuln challenges go, because a lot of them are implementation issues that you can just spot in the screenshot, whereas this is more of a incorrect use issue. And like you were saying, it helps to check the module that's being used, which is why you put the link for
it does help.
the GitHub.
You would expect to see some code indicating that something's getting verified, like just calling it process JWT kind of indicates that it's not verifying it, but it's not necessarily explicit. But I do feel like this is something you could, in theory, at least have an idea of what's probably going on, just from the screenshot. But yeah, fair point. I mean, I tried to keep things all in the screenshot in this case. It does help to look a little bit deeper, but not too much.
Yeah, no, I think it was cool. The way the challenge was a little bit different, so that's why I was calling that out. But yeah, so with that out of the way, we can get into some of our topics. Our first topic here is a Project Zero post talking about some Zoom bugs, two specifically. One being an info leak that was useful for attacking multimedia routers or MMR servers. Another being an buffer overflow that could hit both MMRs and Zoom clients. So there's a bit of nuance going on there with the architecture of what's happening. Z, I'll let you take this one as well.
Yeah, and I'll say that as a post, there's also, as usual with a lot of these Project Zero posts, a lot of background on this and some side discussion to be had. But the two issues, I think, are more readily understood just by going to the Project Zero bug tracker, although the post does add in a slight bit of extra information. I actually pulled up the wrong one here. So first issue, buffer overflow when processing chat messages. Pretty much exactly as it sounds like. What they found was effectively a disconnect between the lengths being used. So the multimedia router will process the messages into this what was the type, message db underscore t type, process it into that, and it would have effectively, it would read one length out of that message structure as here's the length of the buffer we need to allocate, but then when it actually goes to read the string length, it'll end up using a value that is out of the message itself rather than out of the wrapper. So an attacker can use a different size between those two locations, leading to that read string with length function overflowing because you provide it with a much larger string length at that point rather than when the checks happen at the message DB type processing. And that just comes with any sort of text message coming through the MMR server, gets processed in this way, hits the client, and can be or hits a server and can be exploited there. The other issue is the info leak, which I thought was a little bit interesting, and the post actually added a little bit. The Project Zero post added a little bit of extra data about what was happening here. They offer kind of a variant type that can be a number of different types, from an I8 array to I8 pointer, I16, I32. Lots of different options there. One of the ways that they use this is for the username being sent over, it'll send that as a I8 array, or indicate like it's an array of characters effectively. In the browser as a client, it can't actually use or it can't process just an I8 array like that, so it wants to be sent a string. Which is where the bug ends up happening. And that's a little bit of data that's added, or a little bit of detail that's added in the post that wasn't in this bug report. In the bug report, it just talks about the bug being it converts that variant I8 array into a STD string without actually checking whether or not it's null terminated. Since you can send a string that's not null terminated, it'll have, potentially sensitive information in the adjoining memory, or in the adjacent memory.
Yeah, it's worth calling out there that I think there is a bit of a misconception sometimes about how the string container works in C++, because it's easy to think like, C strings, they're going to be null terminated, right? But the string container in C++ is different. It doesn't, like, there is no concept of null termination in C++ strings, or STD string, I should say. Basically, STD string is just a container where you have an auxiliary data buffer and then it has an internally tracked size. So it's
Yeah, I
just
think it
kind of one of those
runs.
differences between how C strings work and how lib C++ strings work.
Yeah, and somebody might correct me on this, but I believe it uses the size before the actual data array. So very similar, like same way Java stores strings, size and the actual array to that size without actually um needing the null terminator there.
Yeah. And this is a somewhat common issue. Like it's definitely been. I feel like we've covered one before on the podcast that was very similar. Just not respecting the null termination of strings when dealing with C API functions. Because it is one of those things that you have to make sure to account for, and it's easy to forget about or mess up. I did want to jump back a little bit on the first issue as well and just mention that the way that overflow worked, because there was the two different sizes where like the allocation size was taken from the packet and the actual string size was being read. That's a pretty useful overflow to have because you can control how much you overflow and the allocation size. So the heap shaping there is made a good deal easier than it would be if you couldn't control like the allocation size, for example. And that's relevant when they get into the exploitation side of things because they talk about how they were trying to, I think they use fast bins ultimately to try to exploit the issue. They did have some problems, unfortunately. The exploit was like pretty unreliable. I don't know how much we want to, or if you wanted to get into that, Z. If not, I'll get into a little bit of that here.
Go ahead.
All right, so yeah, they tried to chain these two issues to get them to work together. They were heavily relying on Frida because this is closed source software, and they're dealing with these kind of complex state machines, right? So you had to have some specialized tooling to even get the introspection that they needed. Um, After some heap shaping, they were able to use the buffer overflow to smash an adjacent object's virtual call. They said it worked like once in every 10 times they tried to trigger it or so. But after that, it became a lot more difficult to actually abuse that code execution primitive, because while the binary at the time wasn't position independent for the MMR server, the libraries were still ASLR'd. So getting your exec gadget with like being able to execute a shell or whatever was still very difficult because those are going to be in libc, which is going to be randomized. On top of that, the MMR server is restarted hourly, so a failed exploit and thus a crash was very expensive in terms of how long it would be before you'd be able to try again. So they tried to get a reliable strategy going by getting some object that they controlled to set up a fake vtable and get some strings created that they could use as a parameter to exec v. And then they tried to find that object with the info leak that Z detailed. But they couldn't really get that working out because null bytes kept getting in the way, which was a big problem because the info leak was string based. And the objects they were able to leak didn't really contain useful pointers very often. They, as a last-ditch effort, they tried abusing log data and a type confusion on the node ID variant. So using the overflow to try to cause type confusion and get log data, abuse the log to try to create strings that could get used. But that also didn't work out because the timing wasn't practical. You basically had to get a log entry logged at the same time that the bug is triggered, and he just couldn't get packets sent fast enough for that to work out. So unfortunately, it seems like exploiting this reliably, just they couldn't get it working, even though the vulnerabilities were like
want to
pretty
jump
powerful.
in just really quickly. I believe this was also done by Natalie Silvanowicz. I definitely butchered the last name, but she, not he.
Oh, sorry. Towards the bottom of the post, I saw posted by Ryan, so that's maybe
Oh
okay.
yeah, no,
I
I
was a bit
think like
confused there.
every Project Zero post is Ryan. I think that's
Oh,
just
fair
like
enough.
the blogger system. Yeah, no, the up at the top, it's posted by Natalie.
Oh, okay. My bad.
So we also didn't mention who it was at the start, so good to call it out now.
Yeah. So yeah, as cool as the bugs were, unfortunately, Natalie couldn't really get them, chained together to get a reliable exploit going. Now, moving away from some of the technical details, there were some discussions I saw happening based on the conclusions of the article. Notably, like Natalie was surprised at the lack of ASLR in Zoom MMR servers, though I think that's since been addressed.
I
Because I
would
think that
hope
was talked
so.
about a little bit. Yeah, I think that was talked about a little bit further up the post. Um, as well
I
as some
mean,
of the attack
anything
surfaces
that's
it was
network.
exposed.
I mean, basically everything should be ASLR these days, but anything that's networked definitely should be ASLR. I mean, ASLR and NX are kind of the minimum bar at this point.
Yeah. The other thing that was called out was the attack surfaces that was exposed in the form of non-end-to-end encrypted modes of operation. The other classic point that I think we'll talk about a little bit more is the fact that Zoom is closed source, so the auditing and exploitation that happened here was, using reversing. I think a lot of this was like decompiled code, like manually reversed, and using IDA for that. And the way that Zoom's applications and code is set up, auditing from black box is very difficult and requires a lot of special tooling, like I mentioned earlier. The licensing, they also point out, is very expensive, so it's not easy or accessible for researchers to really get a setup going to look for issues. And that's potentially concerning where products like Zoom have become so popular since the pandemic began, because it does seem like a bit of a soft target in the way that it's not heavily mitigated. Some of the bugs that are found here are fairly low hanging fruit, and it's really hard for researchers to look at. So there was a bit of a discussion I saw spawned off of that. There was also something that you wanted to point out, Z, in regards to the setup. So I'll let you talk about that.
Well, actually, you called out what I was going to bring up, which was just regarding the kind of the open source versus closed source aspect, and just the fact that this research was possible because Zoom allows their customers to set up their own servers, in terms of being proprietary software, but you can still kind of run it and self-host it. I kind of want to call that out because this does fall into that whole open source versus closed source idea. Also falls into the fact that there aren't. So I don't know if a recent thing. I know Apache has like Open Meeting or something like that, which doesn't have the greatest security track record either. But in terms of what a lot of people end up using for this sort of application, it is a lot of proprietary software that isn't easy to look at. And I think it's really easy to just hate on Zoom. Like, oh, Zoom's terrible, and we've seen a bunch of vulnerabilities and issues with Zoom, and I know they've taken a lot of heat before, so basically anything that goes wrong is suddenly jumping on Zoom. It's like, at least they're offering kind of this option. So like some research could be done. I think it would be great if, and this is true for any sort of software that you can self-host at least, if they followed kind of what GitLab Enterprise does, well, GitLab in general, it does when it comes to getting security research done on their more enterprise software, on the more costly software, which is once a researcher has reported some number of vulnerabilities of sufficient severity, like decent vulnerabilities, not like big bounties, they'll get a free free license to GitLab Enterprise, so then they can self-host and do more testing, and they kind of make it accessible without just giving it to everybody who asks for free. And I feel like that's a fair balance that could be done here also, versus requiring that people just pay the $1,500 licensing fee.
Yeah, that's fair to call out. I kind of forgot that that was a common practice, but yeah, I remember covering some other topics in the past where that was part of the reward was the licensing cost. So
I don't
yeah,
think
that
it's
was cool to point
super
out.
common. Um,
I think we've seen it a few times though.
we've seen it a few times. In part, I don't think it's super common because being able to self-host, but still being proprietary software, isn't the most common model out there. Oftentimes, it's either just completely open source and has like a support licensing, or it's completely proprietary and cloud hosted. Having that middle ground of it's proprietary, but you can self-host it, is out there at an enterprise level, but not it's not the most common setup, I'd say. So I think that kind of lends to the fact that thus that model isn't the most common thing. Yeah, Lab's the one that stands out for me, but yeah, I'm pretty sure some others do a similar thing.
So there was a sentence towards the end that I wanted to pull out a little bit and see if we could talk about. That said, I don't know how much we'll really be able to brainstorm. But the last sentence is Zoom and other companies that produce closed source security sensitive software should consider how to make their software accessible to security researchers. Um, that is kind of an interesting point because the broad debate that's always had is like what you mentioned earlier, the closed source versus open source. Um, but that sentence kind of makes you wonder, like, is there a way that you could um, make the software open to security researchers without going like fully open source? Um, like maybe providing some kind of introspection tooling that where it doesn't need the source, but it still allows you to do some debugging or something. I don't know that it was just something that kind of came to mind when I saw that sentence while you were talking a bit earlier, and I didn't know if you maybe had any ideas toward that.
It's a good question, and part of it's what I just said about making so like, reporting vulnerabilities on what is freely accessible can lead to getting a free license. I feel like that's at least one way of bridging that. Maybe not the most ideal thing. It's a hard problem to solve because obviously they want to keep their own intellectual property, their own property, which just hinders security research. Like, we see that with Apple. We often complain about how closed off like their hardware can be and how difficult they make it even for like getting a research device is such a pain and has all the limitations with that. I don't have a good solution. I would say just as a stepping stone though is certainly Zoom should have internal audits being done and assessments of their software being done both internally and by a third-party company. I do think it's important that, one, there's a good internal security process, and two, that's augmented by regular third-party assessments. Just another set of eyes, don't have the same corporate culture, don't have, all that same background taking a look at it. As like the first step in that security maturity is getting the third parties in there also to help with doing some of the security research, and then making those assessments and the vulnerabilities public. The exact detail of those, I wouldn't expect them to like make every vulnerability ever found and all the details of the code public, but making that information public is kind of the next step to supporting the researchers, is supporting third party but research firms. And then having the mechanism for those sorts of firms to reach out, for like a verified firm to reach out and say, okay, we're a verified firm, we would like to, or one of our researchers would just like spend some time doing this sort of research. And I feel like that could maybe be a stepping stone towards having something for the public in general. The public is where it becomes a little bit more difficult when it comes to like offering it at like the bug bounty scale for absolutely anybody. The concern there is, oh yes, I'm a researcher, I want access to the product, but I'm also going to use it for my, small business on the side. But it's totally just for fuzz testing. Like kind of getting into that room, I could understand a company being a little bit wary about that.
I feel like providing the introspection tooling does hit like a good middle ground, um, and should be worth consideration, because like you don't need the source code necessarily to make use of that, but it would go a long way in the security research, because from this blog post, it seems like the most troublesome aspect of it and what made it the biggest pain in the ass was getting that introspection, having to use Frida to do all this hooking. And like there were a few statements in there that stood out to me when I was reading it, that were like, I would have tried to pursue this, but it would have required so much special tooling to be set up that I just didn't uh, feel like it was worth it to pursue that route, or something along that effect. Um, and I feel like making those issues less painful could go a long way in like improving the security of the product. But I don't
But
know.
it can
I feel
also
like that's something
go,
worth considering.
but providing that sort of introspection tooling can also go the other way and make it easier for an attacker by creating new attack surface. Being able to attack that. So, I mean, that would be then on like maybe on a separate build, but then you have the case of, well, bugs that are in one and not the other and needing to maintain a separate build. Maybe, debug symbols. That could obviously be included and would be an asset to most researchers in terms of understanding kind of what the code's trying to do just through the naming conventions. I'm
Yeah,
not
that's
sure
a fair
what it
point
would
with the
look
separate
like.
builds.
To, I mean, in a sense, I want to agree with you and say, like, yeah, okay, include like introspection tooling and being able to do that. I just don't know what that would really look like for a company to provide something like that. And it feels like to me, it's just creating too much extra work, hassle, and attack surface.
You would definitely have to take some steps to ensure that it didn't increase the attack surface. Um, Separate build is obviously the easiest, but like you said, that comes with its own problems. So yeah, I mean, there's trade-offs. You would have to consider everything, but um, it is a route that I think could be worth exploring. Other than that, though, I don't really have many other ideas, because, like you said, it's, especially when it comes to the public eye, it's a hard problem to solve if you don't want to just go all the way and just go open source on it. So
Yeah, like I do feel like I said, as a stepping stone, opening things up to like validated, verified researchers is a fair move. Like those who work for a consulting company, you look at that and opening it up just to them. It's a small step, but it's a very positive step to at least be that, because a lot of the professionals in the industry are doing that, or even like established bounty hunters Again, you don't want to necessarily open it up to everybody. I mean, personal opinion is opening things up, but I understand where a company wouldn't want to. And I feel like that's even a good stepping stone versus just everybody.
Yeah, kind of like the private HackerOne programs, for example, something like that,
Yeah.
where established researchers on the platform can get invited. Yeah. All
Yeah,
right.
I mean,
So
I'd like the option for just any professional to be able to reach out into some of those types of programs. Because this comes back, we talked a long time, I think it was Votes. Was that the voting platform with the security issues that were going after the researchers?
I
I
think it
think it was
was, yeah.
Votes. We talked about quite a while back. And they obviously are hostile to researchers, even though they do have some third-party audits and such. Like they were very hostile to the researchers, and just sometimes the researcher is just interested in doing something on the side, isn't necessarily wanting to establish like a proper uh client relationship with them. Just I'm curious about this technology, and I figure it would be interesting to hit this target. And companies having a actual program for that, I think, would open things up to researchers quite a bit more if they just had some system for validated researchers to uh, get access or do some work that's not requiring them to always pay the full price.
Yeah. All right. So we'll move on to our next post here, which is also from Project Zero, Ian Beer this time. We have an XNU kernel use after free, and a fairly involved one at that. This is probably the longest bug tracker report I think I've ever read. Um, this is an XNU's IPC port subsystem, which is like interprocess communication. It's one of the many weird custom rolled systems that Apple deploys. Um, and it's also been a fairly popular target in the past for both exploitation primitives, for post-exploitation, as well as attacking directly. The vulnerability here is in the IPC port copy send function, or rather more how it's used specifically. It's a pretty weird function in the way that um, it's for copying and sending data over an IPC port, but it tries to account for a bunch of edge cases on the state of that port, because an IPC port can be in various states. For one thing, the port being passed could be a sentinel value, where it's like IP null or IP dead, in which case it just tries to like return that same thing back. It has this is IP valid on it. The other possibility is that it's a valid port, like it's a pointer to a port, but that port is dead. It's had the IP bits active flag cleared, and it's like being cleaned up. Um, in that case, it will also return the IP dead value. And then finally, if it's a valid live port, it'll bump the reference count on that port and then return that reference, giving you a write to it. And I believe write in this case just means like a reference count increased, like reference to that object. The problem that Ian highlights is like, what's the difference between passing a pointer to a port that's dead and a port that isn't a pointer but just has that IP dead value? Where, well, there are some cases where that could be problematic, because if you pass a valid port that's dead and receive the IP dead value back, it means the receive write for that port was destroyed. Um, and if the return value of IPC port copy send isn't properly checked, um, then obviously that reference count is never bumped because it thinks it's dead, but the calling code was never made aware of that, and that the reference count wasn't updated if they don't check the return value. Um, Ian then goes into some details on a path that had this problem of not checking the return value, being IPC write copy in 2, and how the failure case could be reached. This part was a little bit less clear to me, to be honest, because it involves a lot of intimate knowledge of mock messages, and XNU just isn't mine or Z's area, so we had to take a lot of what was being said there at face value. I believe the ultimate strategy was to fill up a destination port's message queue to try to trigger some logic that'll destroy the message writes, and that would set the port as a dead port, by clearing the flag, and then you have that issue of the reference count desync, or the object state desync, I guess. But yeah, I mean, ultimately the problem there is because of not checking the return value, they don't know that the reference count wasn't updated, and it's possible they access a reference to the port that's been freed, which is where the use after free angle comes in. Hard to really comment too much on the like exploitability of this issue, just because, like I said, XNU is kind of its own thing. It's a bit weird with how it even with how the heap works, because I think they have like heap isolation and stuff too. So there's a lot more mitigation work. That's Apple's entire game is mitigation. So hard to really comment too much on the exploitability of this. Although I think Ian does go into
Yeah,
like a
and
bit of a strategy layout in like a further down comment in the thread.
yeah, and one of the comments in the thread, he ends up talking about some of the hardening measures that have been put in place since the last time he tried to exploit it, and kind of goes into, some things that could maybe be done and have a higher level look at how it might be exploited, or kind of what exists there, what considerations there are. As you've said, this is a fairly lengthy and involved post.
Yeah, the exploit strategy section I did try to give a read, but it's pretty inaccessible if you're not familiar with XNU and the code that's being talked about, which is totally fair. This is a bug tracker report, right? It's not like a full write up or anything.
Yeah, it's
Um,
for the devs.
yeah, like to the people that this report is intended for, like this makes a lot of sense. But yeah, it's hard to really cover here, unfortunately, because there's just too many details that we're not really aware of. But yeah, I mean, if you're interested in that and you're familiar with XNU, I would recommend like taking a look at it, because I think there is a lot of valuable information there, especially when it comes to talking about the hardening and some potential thoughts on how to get around that. It seems like kind of a treasure trove of information on the exploitation side of things if you're into Apple stuff. So I'd recommend checking that out if you are.
Yeah, there's definitely a
Um,
lot there. It's as a bug, it's kind of an interesting bug, just in the sense of having. He talks about actually right at the start are these looking for functions that have those unexpected semantics or obscure and rare failure case, and it is just kind of a case of that where you got this function that generally does this one thing where they talk about with the right. In general, it does that except in these edge cases where, so you have the two return values, IP dead or dead port, both giving you that IP dead response, and not check or basically not checking the return value. It's just an interesting thing to point out, because it is common to see these little kind of in a sense, almost one-off functions that end up getting misused like this. And he talks a little bit about what the developer was probably thinking, in that they wrote the comment indicating their purpose of the code at the top of the function. I just thought that was kind of an interesting thing to point out here, because it is such a common thing. It's just having these functions that don't quite behave how you expect, but are easily misunderstood.
yeah, it's trying to account for a lot of things. So it makes sense to try to verify that anything that's calling that function can account for all those different like potential return values.
Yeah,
Or
has the
in this
same
case, doesn't
assumptions.
account for it at all. Yeah.
Yeah, has the same
Because yeah,
assumptions as the author of the uh, core function did.
yeah. When you dig down to it, like the main problem there is just not checking the return value, which is fairly simple, but to understand the impact and how that can be taken advantage of, yeah, there's a lot of intricate details on the control flow and what's happening there. Next, we have a Linux kernel bug that was introduced in kernel version 5.1 in FS context's legacy parse param function, which is notable because this is in the kernel core and thus affects lots of things that use Linux, though you do need capsys admin capability. Though, like, while that may seem like a high ask, it isn't really because of user namespaces being a thing. The issue comes down to a faulty bounds check they perform on a provided options length when they try to compare it against the system page size -2 minus the context data size. As you can probably guess with the math going on there and the fact that subtraction is happening, if you pass a context data size with a value that is close to the system page size, which is usually 4096, So if you pass like 4095, for instance, it'll underflow and render the bounds check essentially useless. So pretty straightforward integer underflow issue here. This would lead to a heap overflow via the mem copy, which uses the length. Um, Given the fact that your memory corruption here basically allows you to break a bounds check, I believe you could pass whatever length you wanted here and overflow by however much you wanted. Your overflow would also be on legacy data, which is always allocated to be one page size. So in most cases, that would fall in the KMalloc 4096 cache, which is a pretty good cache to overflow because it's one that's not going to be used super often compared to the smaller ones like KMalloc 32. So it'll be easier to do like heap feng shui, and so likely a pretty nice exploit could be written for this bug too. But yeah, I mean, anywhere you see these kinds of weird size checks where they do, like, especially like -2 minus size, where it's not even really intuitive, like, why they're doing that calculation the way they are, um, then it's probably worth investigating. Um, and in this case, yeah, they just didn't account for a super large size being passed in the options parameters. So
Yeah, which
yeah, I mean,
is like, as a developer, really easy to not always be thinking about the, especially the underflow side of things. I mean, overflows feel like that's a bit more natural to think of, but then, on the subtraction side, you've got the same sorts of issues, just, that little bit different. It seems to me like subtractions, I mean, overflowing with the additions tend to be a bit more popular, just because additions used more. But I feel like as a developer, it's so much easier just to forget about that underflow side of things too. And in this case, yeah, like the patch did just change things to size plus len plus 2 greater than page size. So changing it over to an additive check basically ends up resolving the issue.
yeah, it's just easy to not account for all the problems you could have when you're doing math with unsigned values, which obviously with sizes and stuff in the kernel they have to be. So um, yeah, but like I said, like anywhere that you have those kinds of weird calculations, it's good to look at, and yeah, especially where this is in the kernel core. Um, this could impact a lot of things. I think I saw this bug being mentioned in the context of how this is gonna impact like Kubernetes and like cloud stuff, which I don't know how much I can comment on because I don't know how common it is to get into an attack scenario where you have capsys admin, because like on desktop or server, it's fairly easy to get that capability because user namespaces are enabled by default in a lot of cases, which is really stupid, by the way. But they are. And the ability, like one of the things user namespaces let you do is you can sandbox yourself into a namespace, grant yourself a bunch of capabilities. And obviously, like you're a fake root, you can't actually do things on the host file system that would be dangerous, like cat etc shadow or something, but you have these fake permissions that let you access kernel attack surface that's usually privileged off. So user namespaces are a very powerful thing,
I mean,
and
if they just
that's
wrote
the
proper
reason
kernel
why
code that was, secure, you wouldn't
if
have the
they
issue.
if
If
they
they
just
just
used
wrote
Rust, it would
bug-free
be
code.
fine.
Oh yes, yes. Just use Rust though. Just write bug-free code. I mean,
Exactly.
that is kind of thing. Like in theory, this shouldn't, because they're not actually letting you do things outside of the little sandbox. Having capsys admin shouldn't introduce any new bugs. Of course, it's new attack surface, more places for bugs. And there are bugs in the kernel.
Yeah, especially in those like capability gated pieces of code because they're not as well audited. Um, So yeah, because of that reason, with user namespaces being so powerful, I would imagine that a lot of security sensitive areas would disable them. That said, I don't know if they're disabled or used in like the cloud. That would be something I'd be interested in, but
Well,
it's
so
something
I'm
that's hard to
actually
comment
thinking
on
with
right now.
Kubernetes, I wish I knew more about the specifics on how it implements. So So no, it doesn't use Docker. So Docker would be a case where, you need namespace because Docker works on namespaces. Kubernetes, I want to say, runs things under a VM. I feel like we've actually covered some VM escapes under Kubernetes. I just don't know if it runs a VM and then it runs Docker under the VM for some. So it has the VM isolation to an extent. Actually, I think that is what happens. So like you'd be able to escape still into like the VM some. Under Docker, you kind of need the namespaces, like because it is a very useful feature to have these namespaces. Adds a lot of attack surface, but it's also quite useful.
Yeah, and anywhere that it's used, it's going to be impossible to just disable in the interest of kernel security. Um, and I think in many cases, kernel security might not even really be thought of when using user namespaces either, because, like you said, it's not something that you would intuitively jump to and think about unless you kind of knew the implications of how the namespacing works on the kernel side. So yeah, there are some potentially interesting implications on like the cloud side of things. That said, I can't comment too much on that because cloud just isn't something that I work in, and it is a very like specialized field where it's going to have its own kind of setups. It will be taking advantage of things like namespaces in some cases. So yeah, it's an interesting area to think about.
I mean, I'm sure
But
within the cloud, there are still places where you'd be able to get this, and it'll at least help in some extent. I think a lot of the hardened systems like KDAS or Kubernetes will have some defensive layers in there. Like I said, I believe if this were to be exploitable under Kubernetes, I've seen a little bit of discussion. I didn't actually go and read it, so I'm not sure kind of what the consensus was there. Given the fact that it's being brought up, I'm assuming actually it is. Um, you're still kind of being left where you're inside of a VM, so like you still have to do more work to escape, but you have more attack surface to play with. Or you can do just things within that VM itself, if Kubernetes works the way I think it does.
yeah, but bottom line is the fact that it's in the kernel core means there's a lot of potential areas where this could be abused. So this bug has received some attention. People trying to push others to update systems and patch and whatnot. So yeah, it's been getting a bit of traction in that respect. Our last vulnerability is another kernel bug, though this time it's not in kernel core or even in like the kernel tree. This one is in the Kcode's NetUSB kernel module, which is used by various network device vendors for routers and whatnot. It's used by vendors including Netgear, TP-Link, D-Link, Western Digital, so a lot of popular vendors for that kind of equipment. They start off by detailing a bit of the internals of the kernel module. Basically, just the fact that there's this handshake process that takes place between the device and the router using a signature exchange, which is encrypted with AES. And then after successful handshake, the router will run a command loop where it'll process whatever commands come over the network, or what they call the software bus, which you'll see it referred to as in the code snippets that are posted. The vulnerability is in the dispatch normal EP message out handler for the unlabeled command of hex 805F. Those who are watching can see there's some decompiled code here where a user supplied size is taken from the socket data and used to allocate a kernel heap buffer with kmalloc. Um, and it allocates using the supplied size plus hex 11. And, well, again, with the integer overflows, passing a large size, like size max minus hex 10 or whatever, will cause that allocation size to overflow, wrap around, and give you the minimum allocation size, which should be kmalloc 32. Meanwhile, the unadjusted size is used for writing into the allocated region. Something I thought was awesome with this report was the second half talks about the exploitability, which is something that we don't always see, unfortunately, with some of these kinds of reports. They comment on the fact that your overflow primitive will always be in the kmalloc 32 cache, which isn't ideal. That is a pretty active cache, and you're probably gonna have to use some tricks to even exploit this by stalling out other system processes with using like affinities and tricks like that. Because otherwise there's probably just going to be way too much movement, and you're probably going to hit something or overflow into something that you don't have set up or controlled. Um, Though they mentioned that because of the fact that there's a timeout here of 16 seconds for receiving the data, it could eliminate the need to create holes in the heap, since the struct can be overflown, or the object can be overflown at some later point after it's allocated at a controlled time. So you kind of have this window where you can get the overflow target allocated, set up your target object, and then trigger the actual overflow later on. And while this is a linear buffer overflow that technically would use a really large size, the underlying function that does the copying will only copy like to a maximum of the received size. So you do control how much you overflow, despite the fact that you have to pass this really large size to cause the exploit condition. So yeah, it seems like a fairly ideal bug for exploiting actually, even though the stability might be impacted by the kmalloc 32 fact. But um, yeah, overall seems like a pretty positive exploit scenario.
I mean, stability might be, but especially with such a large overflow, you could also, in theory, if you allocate like the same object if you're able to have some primitive to do that at least many times, you can probably make this pretty stable by also doing basically overflowing multiple objects in one go, and then just as long as one of them hits, you get your exploit.
You just have to hope you don't smash something that
That
you
gets
can't
used, yeah.
control that gets used. Yeah.
Yeah.
That's the main concern. But I think with enough tricks, like if you could do the CPU affinity trick I mentioned, where you can like try to stall out other processes, I think you could make it pretty viable. Um, the fix for the vulnerability here was simply to add a bounds check to ensure the supplied size is somewhat reasonable. I think they checked that it doesn't exceed like hex. Well, it's still a large value, like hex 1000000 or whatever, but it's far below what you need for an integer overflow on a 64-bit size. So it's good enough for what they're trying to prevent here. But um, yeah, I mean, again, just it seems to be a theme of the episode with these like somewhat trivial integer overflows. Like I think this is like the third or fourth issue we've covered that hits on this underlying problem. So yeah, just yet another area where that can be abused, and another exploit scenario that's pretty ideal because you can control the overflow size. You can control the well, actually, in this case, you can't really control the cache being hit, unfortunately. But there are some points in your favor as an attacker. So yeah, just another kernel bug that's relatively trivial as far as they go.
Yeah.
So yeah, unless you have anything to add on that topic, Z, I think we'll move towards wrapping up the show.
Well, I do, not on that topic actually, but I do have one last minute topic, or I guess it's a shout out actually. We talked about this during the last episode, but there is a cybersecurity humble bundle going on. Um, so if I can pull that up here. I won't talk about all the books this time. There are a couple in here that might at least be of interest to some of you listening. Malware Analyst Cookbook, Art of Memory Forensics. This is a series out from Wiley. So the last bundle we talked about was No Starch Press. Wiley also does decent bundles. Good mix of books here. I went into detail about them, or more detail about them during our last episode, so you can check that out. Mentioned too, Practical Reverse Engineering would be the other one, I think, of particular note here. For kind of the exploit dev side of things. I don't know if there are any you want to shout out in particular, Spectre.
I think there was just the one that I mentioned on the last episode, like Practical Reverse Engineering. I thought that was a pretty good, at least like a surface level introduction into RE. It doesn't go super deep on any aspect, but it covers a wide breadth of topics. Windows kernel, ARM, x86. So yeah, I like that book. It's one of the books that I have a hard copy of. Secrets of Reverse Engineering isn't in this bundle, right? I think we just touched on that
We just talked
tangentially
about it, yeah.
Yeah, okay. So yeah, that's the only book here that I could really like recommend. I am interested in some of the cryptography books because crypto is an area that I'd like to learn a bit more about, but I haven't read the books that are mentioned in this bundle yet, so can't really comment too much on those. But it definitely seems like a bundle that's worth checking out, and it's probably one that I'll pick up actually. So
Yep.
Yeah,
And I think
good to shout that out again.
and the charity for this one's EFF. Good charity. Good place to send money to. And also, if you don't know about it, I'll also just shout out the fact they do also do a um at least the podcast that I enjoy. I think I've linked them at least a couple times in our Discord before when they've done vulnerability related things, but yeah, honestly, just wanted to shout it out here. If you want more information about some of our thoughts on some of the books, that's during the start of the last episode. Other than that, I have nothing to add.
All right, cool. So yeah, that's everything that we have for this week. Thank you to everyone who tuned in. The VOD will be up on Twitch immediately or on YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. If you want to join the community, follow our Twitter and join our Discord. Links for those are down below or in the chat. With that said, we'll be back again next week on Monday for our bounty episode and Tuesday for the binary episode. You can check out Twitter for the alerts of when those are live and the Discord as well. And we'll see you next week.